Welcome to this explainer, everyone. I am absolutely thrilled to have you here today because we are going to unpack one of the most incredibly engineered pieces of superhero gear ever put to the screen. If you're a fan of the Caped Crusader, you already know that the suit from Batman v Superman was just something else entirely. It was terrifying, it was ultra aggressive, and honestly, it was literally pulled right off the comic book page. But beyond that amazing aesthetic, there's always been this lingering mystery for those of us who love geeking out over the details. Like, what exactly is this specific, hulking suit actually constructed from if we look at it through the lens of real-world materials? Well, today we are going to dissect the anatomy of Gotham's Guardian and uncover the real, hard science behind this iconic armor.
Welcome to our channel, where we explore the darkest corners of the cosmos, the mysteries, the threats, the unknown. This is space like you've never seen it before.
So, let's jump right into the core question. What is the new Batsuit made out of? The first thing you notice when you look at this suit is how heavily it mirrors that classic, super bulky comic book look. I mean, just look at the massive, imposing black bat emblem stretched all the way across his chest. We aren't dealing with the sleek, segmented puzzle piece armor from other movies. No, this is a solid, intimidating, almost monstrous silhouette. To figure out the materials behind it, we've got to break this thing down piece by piece. It makes sense to start right at the center of mass.
All right, clue number one, the bulletproof bat symbol.
If you really scrutinize the set photos, you'll notice something super fascinating about the chest. That giant bat symbol, it physically protrudes from the rest of the suit. It's got actual depth to it. And even more telling, you can spot several distinct bullet impacts on the symbol itself, but they haven't actually punctured the suit. This immediately screams heavily reinforced armor. But why focus the absolute heaviest plating right in the center of the chest? Well, it brilliantly highlights his tactical genius. It all goes back to that legendary quote from Frank Miller's The Dark Knight Returns, which, by the way, heavily inspired this suit. He says, "Why do you think I wear a target on my chest? Can't armor my head." Batman's engineering logic is simple, but it is flawless. He's deliberately drawing enemy fire away from his exposed jaw and right into the most heavily reinforced, bulletproof part of his entire body. Which brings us to the first reveal, Kevlar reinforcement. Because the symbol sticks out and just eats direct gunfire without failing, we're definitely looking at a dual-layered system. And the molded pad beneath the surface? Based on all the evidence, we can confidently say it's Kevlar. Now, Kevlar is this incredibly durable, lightweight plastic created by DuPont, heavily used by military and law enforcement. We all know it stops bullets, right? But what's really wild is that it's also remarkably resistant to extreme temperatures. It won't just melt on you. And here is the kicker. Kevlar is highly resistant to chemicals. Think about it. If you're a vigilante spending your nights fighting totally unpredictable rogues who love tossing around vats of acid and laughing gas, yeah, looking at you, Joker. Having a chemical-resistant chestplate isn't just a perk, it's absolutely crucial. But here's where we run into a bit of a roadblock, the physical limitations of Kevlar. You're probably wondering, well, why doesn't he just make the entire suit out of molded Kevlar? It's a fair question. The thing is, while molded Kevlar is phenomenal at stopping a bullet dead in its tracks, it is incredibly stiff. It's rigid, it doesn't want to move. And Batman, he requires extreme flexibility. The guy is a master martial artist, doing flips, grappling up buildings, and throwing roundhouse kicks. A thick, full-body Kevlar suit would essentially turn him into a statue. So the chest gets the thick Kevlar plate, but that means the outer skin-tight material covering the rest of his musculature has to be something completely different.
And that leads us to the big twist, the skin-tight mystery material.
So we know it's stopping the bullets at the center of mass. But what on earth is wrapping the rest of his body? What gives him that terrifying, durable protection while still letting him move like a ninja? I dug into this for a while, tossing around ideas like woven titanium or some fictional super fabric. But the actual answer, it is so much more grounded and honestly kind of mind-blowing. The flexible outer layer of this batsuit is derived from high-performance vehicle tire components. Yep, I know, it sounds totally crazy. Batman is essentially wearing tires to fight crime. But before you write that off, stick with me here, because there is cold, hard, brilliant science behind why this is the ultimate material for surviving a typical night in Gotham City. Let's get into dissecting the tire components. Think about the massive amount of engineering that goes into high-performance vehicle tires. They have to survive immense pressure, extreme friction, and literal changing seasons without failing. To understand how this tech works for a superhero, we can break down 3 distinct layers borrowed straight from tire manufacturing. Step 1 is a specialized rubber compound. Step 2 uses form-fitting fabric cords. And Step 3 involves reinforcing steel cords. When you fuse these 3 elements together, you get a material that is virtually indestructible but fully adaptable. Let's look at exactly what each layer is doing for our guy. First up, the specialized rubber compound. In the automotive world, specific rubber mixes are formulated to maximize performance under really extreme conditions. For Batman, this means his suit flawlessly adapts to whatever physical environment Gotham throws at him. Freezing rain, blistering heat, sliding across broken glass, the rubber handles it all. Plus, this specific compound is exactly what gives the suit its foundational, dark, matte black look. It absorbs light, letting him blend perfectly into the shadows to keep that terrifying edge. Now, beneath that layer of rubber, you have 2 very different types of internal cords, acting kind of like a tag team. First, the fabric cords. These manage temperature fluctuations based on the friction the suit takes. But more importantly, they provide crazy elasticity. This is the secret sauce for how the suit stays perfectly skin-tight, hugging every single contour of his muscles. Then, you've got the steel cords. These are the heavy lifters. They provide the raw tensile strength, holding the material together so it doesn't just shred under immense pressure or impacts. So how do we go about balancing armor and flexibility? Because adding steel cords introduces a massive engineering headache, right? If you just pack a suit full of steel wire, it becomes completely stiff. The creator of the suit had to make a really strategic trade-off here to ensure Batman could still bend his joints. The solution is actually an absolute masterpiece of functional design, achieved by varying the density of those steel cords. For example, the main bodysuit uses a very low density of steel cords. This maximizes the flexibility he desperately needs for acrobatics and hand-to-hand combat. But then, look at the cowl, the boots, and the forearms. Those parts don't need to bend much, but they absolutely need to block a knife or absorb a crowbar swing, so they feature a super dense concentration of steel cords. It literally turns those specific areas into rigid, impenetrable armor. It is such a brilliant, localized use of materials.
Finally, let's look at capes and combat knuckles.
Okay, so we've got the Kevlar chest plate, the tire rubber outer layer, and the strategically placed internal cords. But you gotta finish off the look, right? The anatomical breakdown isn't complete without the accessories. The knuckles embedded right into the gloves act like high-tech brass knuckles. But instead of heavy, clunky brass, they're forged from a super dense blend of lightweight metals, advanced carbons, and plastics. It gives him devastating striking power without weighing down his hands at all. And the cape? It's not just a fancy piece of Gothic cloth. It's actually a specially formulated aerodynamic variation of that exact same core rubber compound we were just talking about. It's designed to flow dynamically in the wind rather than staying stiff, giving him that terrifying silhouette and, of course, functional gliding capabilities. And there you have it, the complete, real-world anatomy of an absolute cinematic masterpiece of a Batsuit. From Kevlar chest plates to high-performance tire tech, the Dark Knight's armor is actually rooted in some seriously clever, heavy-duty science. But that brings us to the end of our investigation for today, and now I really want to hear from you. What impossible piece of fictional superhero engineering should we investigate the real-world science of next? Are we looking at Captain America's shield? Maybe Iron Man's repulsors? Let me know, keep that curiosity alive, and thank you so much for hanging out with me on this explainer. I'll see you in the next one.
If this video made you think, hit like, share it, and subscribe to this channel. Because the next mystery is even deeper. Until then, stay curious and keep looking up.